Hey, hello, welcome to the show. It's me, John Park. It is time for John Park's workshop. So if that's what you're looking for, you're in the right place. So thank you for stopping by our chats. We have people over in our YouTube. Hello, Dave Odessa and Johnny Bergdahl, and anyone else who comes on by. Hey, Connor McCarter, nice to see you. Afternoon. And our Discord chat, which is this right here. No, whoa, I broke a thing. Hold on, let me put that thing I broke back. Come back here, thing. That's just a black hole. That's not Discord. How about that? Yes, that's Discord right there. So if you want to go and hang out in our chat, you can head on over to adafru.it/Discord and then look for that live broadcast chat channel. You'll see it right around here. Can you see my cursor? Yeah, right around here. There's the live broadcast chat channel. You can see here we have a ton of other channels, but that's where people tend to hang out during the live streams. So come on by. Hello, Thin Man and Gary Z, Jim Hendrickson, Mike P, Paul Cutler. Hello. Hey, Andy Calloway. Hey, C. Grover. Thanks for popping on into our chat. So let me know if you got any questions or concerns or ideas or thoughts or things to call attention to during the show. I'll keep an eye out over there. Hey, Johnny Bergdahl, you guys are writing your C++ code, huh? That's what you're up to? Very good. So, got some cool stuff for you today. I think it's cool stuff. We have a Lego lighting project that we're going to get into. If you look right there, you can see it. Lego lighting is the name of the show today. And what else? I have a coupon code for you. I have a little recap of my product pick show. I've got a CircuitPython parsec that I think is particularly neato today. And maybe that's it. And then the main project, this Lego lighting project we'll get into. Oh, and actually I'm going to show you a little schematic and PCB layout I've been doing for the wave shape fader project that we looked at last week. I put together a board and sent that off, and it's being made over at JLC PCB, and they said they've shipped it already, so that's pretty quick. Hopefully I'll get it in the next week or so, and then we can put it together and see if it works. So to start off, I will encourage you to head over to, oh look, I'm gonna have to fix this too, aren't I? Yep, I missed that one. I missed a couple, sorry. Let me go ahead and point that at my Chrome browser. How about, that'll do. Look, that's the Adafruit website right there. Adafruit.com, head on over there. Hey, Jeff, nice to see you over in the chat. P. Karina Hurry used the parsec on a Trinky, last week's parsec on a Trinky. Oh, cool. Maybe this one will be useful too. It's along the same general concepts, so we'll see. head over to Adafruit and you will be at the store. That's the Adafruit store right there. You can see some products that are pulled out there, some info on shipping for the holidays. And if you want to get 10% off in the store, you can use this week's coupon code, which is that right there, VILLAGE. It takes a village, right? Village, that's going to get you 10% off in the store today. Hey, look, I can move it right there and get it out of the way of this web page. If you head to products and click at the top here, new products, you can see what some of the cool new stuff is. We have some coming soon, a bunch of cameras, these OV5640 cameras in a few different styles with different lenses on them, autofocus, and so on. There's also this cool looking Espressif ESP32S3 Box 3. It's a whole little modular kit of stuff. That looks pretty cool. So if, for example, you threw that in your cart, you would get $49.95 as the price. You would get 10% off of that in the shopping cart when you type in Village as your coupon code. So fill your cart up with stuff. It won't work on software or gift certificates or subscriptions, but it'll work on physical things. So pick some nice stuff for yourself, or maybe some gifts, and then type in Village on the way out, and you'll get 10% off. And also, I like to mention that if you just type in adafruit.com/free, you can see what some of the goodies are, the perks of spending a bunch of money. If you spend $99 or more, you're going to get a free PCB coaster. If you spend $149 or more, you'll get the coaster and you'll get a free KB2040. At $199 or more, you get free Continental United States UPS ground shipping, plus the coaster and the KB2040. And if you spend $299 or more, you'll get a Circuit Playground Express for free and the ground shipping in the Continental United States through UPS and the KB2040, as well as the coaster. So if you want to get a bunch of free stuff, you want to see what that stuff is, those are the breakpoints for those different perks, and that is at adafruit.com/free. Jeff says that they got their Pi Gamer, super cool. Hi, MB. Hello, welcome, and thanks for stopping by. All right, what else? So, Village, that's your coupon code. Maybe I'll pop that back up again later. But for now, let me move some things around, and I will talk about my show that happens on Tuesdays. So this is the Product Pick Show. It happens on Tuesday at this same time at 4 o'clock 4 o'clock Eastern Time, 1 o'clock p.m. Pacific Time. And you can see the sine wave tattoos came off pretty well, so that's good. On the Product Pick Show, I pick something new or old but great or recently reintroduced post-parts shortage into the store, give you a demo of it, show you how it works, maybe some code stuff, maybe some hardware stuff, and I give you a big, huge discount on it. It was 50% off this week. Here is a 1 minute and 38-second recap of this week's show. Check it out. There is my product pick for this week. It is the AD5693R 16-bit DAC breakout board. You can tell it to send really accurate, really fine-tuned, fine-grained voltages. I am telling the DAC right now to send out 1 volt. And you're hearing that the 1 volt is being used by my little synthesizer off to the side to tell it what note to play. There you can see we get a really nice smooth. You can hear it better than you can see it on my multimeter just because it's a digital meter. Now I have it stepping down. If I go to a different type of effect with it, you can see we're sending out some really cool stuff. It is the AD5693R 16-bit DAC breakout. Yes, it is indeed. What else? I think that's going to actually be in the version of the wave shape faders project. I was talking with Liz, and Liz has some ideas of using the same physical board that I've built to do some CV, control voltage output, and so that's a really nice way to do that. So I added a little footprint for that on the board and some connections over I2C. So I'll show you that in a moment when we take a look at that. But in the meantime, I'm going to set up here for a CircuitPython parsec. So I'll see you on the other. Okay. Are we ready? I think we're ready. Yeah, that looks good. For the CircuitPython parsec today, I wanted to show you how to use non-volatile memory inside of CircuitPython to store data between power cycles on your device. So what you can see here, I have a macro pad. And right now it's displaying on its little display the number 0, and I have the first or 0th key pressed. As I press other keys, you can see I'm lighting up different numbers there. And as I'm pressing those, it is not only lighting it up and displaying it, it is also storing that number into 1 byte of the non-volatile memory on the chip. What that means is, if I unplug this, it still remembers that 5 was the number that I pressed most recently. So I'm going to go ahead and power that back up. And you'll see as it comes up, it remembers, hey, 5, that was the number. So the way that it does that is by anytime I press a button, I'm displaying it and I am saving that number, whatever that value is, into the non-volatile memory. The way this works in CircuitPython, you are going to key thing here from microcontroller import NVM, non-volatile memory. Then I'm doing some setup of my display. I'm creating a variable called stored number, which is set to the first index or first position of the non-volatile memory. The rest of this is all about setting up the neopixels, the keys, and the display. But down here in the main loop of the program, if I press a key, when that gets pressed, I am storing that number of whatever the key press is, 0 through 11 in this case. I'm then printing it, I'm setting the color on the neopixel, and here I am saving that number into non-volatile memory right there. NVM index 0 equals stored number. So when I press a new number, how about number 10 here, power this off, power this on, it is going to remember the number and display it for me. And this will also work when you reset the board. So we can go ahead and click on the little reset button there, and when that fires back up, it says, yep, 10, I remember that. And so that is how you can use non-volatile memory inside of CircuitPython to store data between power cycles and resets. And that is your CircuitPython parsec. A funny comment over in the chat. Jeff says, hilarious, I'm trying to scroll his code window. I do that too. I do that on videos where I'm like, hey, let's look at that. Let me scroll around. Oh, wait, that's not my machine there. Yeah, so the non-volatile memory is pretty cool because what it acts like is an EEPROM. Even though we don't have an EEPROM chip on these modern devices, it acts like a little piece of memory that can be written to, but it does not require power to keep that data in memory. So it survives power cycles, it survives resets. The block of memory it goes into is actually 8 kilobytes, I believe it is, on this device. And so we can write to all of those little positions, but we, rather than feeling like we're writing to a block and managing all that, we're actually able to just cast these values into individual positions in that memory and then pull that back. A couple of questions in the chat, or statements and questions in the chat. DJ Devon3 says, the non-volatile memory also persists even if you reinstall CircuitPython. I had no idea. That's really cool. P. Curry in a Hurry has a question. How many writes does the NVM survive? Are we talking 100,000 writes like Flash? Yes, this is Flash. It is part of the Flash memory, so it's not some low number like 10,000 or something like you'd find in other parts of memory. So you can write to it a lot. If anyone knows the real numbers on that, please speak up in the chat because I'm not sure. But it acts like it is actually part of the Flash memory on the chip. It's just CircuitPython carves that out and treats that a little special there. So Very useful, right? If you want the state to persist when you turn something off, turn it back on. If you think about last week's project, or CircuitPython Parsec, we had a code selector when we start up, so we could pick which code.py or which .py file we're going to run. So similar kind of idea to be able to save information, run different programs, makes your device a little more versatile. Okay, let's see. Next up, what have we got? Let's talk about. Yeah, I'm gonna jump into the KiCad portion of this, and talk about the wave shape faders project. I actually didn't bring the prototype with me, but I showed last week a simple version I had with just 4 faders. So this idea behind this is going to be 16 faders, and as we position them, we are changing the value of different points in a waveform, like a reverse oscilloscope. This was inspired by this reverse oscilloscope project. And so I had initially put together a sort of a schematic and a breadboard diagram using fritzing. And I've sometimes made circuit boards with fritzing, but it has it's a bit simple and a bit limited, and my main frustration comes in making new parts with different footprints. Can be a bit challenging, or even adjusting the footprints on existing parts. Usually involves a trip to Adobe Illustrator and maybe Inkscape, saving SVG files, bringing them in, finding magical places to save the files. So it's a bit of work. So I decided it is time to learn KiCad. I've used Eagle a bit, I've used fritzing a bit, but I decided it was time to use KiCad. And so, first of all, big shout out to C. Grover, who stepped me through the process of both creating a new footprint based on an existing footprint from the Adafruit Eagle library. So there's ways to open up Eagle files. And I think I'll show this on the show sometime, that process. I won't show it today. But the ability to pick something, pick a board from, a little breakout board from the Adafruit Eagle footprint, bring it in, and then create a new KiCad footprint, and then create the symbol so that all the pins match and do the right things. So this is what the schematic for this looks like right now. So here you can see I've got this Itsy Bitsy M4 Express, and this will work also with the Itsy Bitsy RP2040. The pinouts are compatible enough for me to slot either board in there, so that'll be up to the user. I believe trade-offs will be we can use I2S output on the Itsy Bitsy RP2040, which we can't do on the M4, but we're going direct out of the analog outputs here if we just want to go to a line output and then into an outboard amplification. These 2 pins that I'm using here, A0 and A1, those are the analog DAC pins on the M4. Those are also PWM-able pins on the RP2040. And what you can see is I'm taking the output of those, and those are going into a little resistor capacitor circuit here. So there's A0 and A1. Those go into a 1K resistor to the right and left sides of the plug. That's the little plug schematic there. And they also have a capacitor going to ground to filter them a bit. So that'll help smooth out the edges on the PWM and reduce a little bit of noise, like a high-pass filter on the analog output. So that's our main microcontroller there. And then you can see here I've got a few different peripherals plugged in. So we're using the I2C here, this SCL and SDA, serial clock, serial data. I have those going to the 2, sorry about the mouse centering. I don't have this set up the way I normally use it, so it's jumping the center. So I have 2 of these ADS7830 8-bit ADCs, or rather 8-channel ADCs. So these are able to read my 16 potentiometers by having 2 of these, and these are on the I2C bus there with that SCL SDA. There are my faders there, and those are the 75 millimeter, 60 millimeter throw faders that we have on the Adafruit store. It's the same one we use in our Neo slider. It's the biggest fader that we have, other than I believe the motorized fader is bigger. I think it's like 120 millimeter. But so these are the symbols for the ones that we carry in the store, and I also made footprints for those that match by pulling them out of the Neo slider. So I'll show you what that looks like on the PCB in a moment. So those were kind of what I had going last time, but now I've added a couple or 3 things to it. On Lady Ada's suggestion, she said, hey, what about a rotary encoder? That'll give us some ability to do input if we're reading the faders, but we want to choose a different mode. We've got the rotary encoder, which has a push button on it. So those are just going to some digital pins, and you can see those are encoder A, encoder B, and encoder switch. Those are going to pins D6, D9, and D10 on the Itsy Bitsy. And then I've got a DAC output for control voltage, this one right here, the AD5693R. That's the same one that I showed on Tuesday's show, and this is the one that Liz wants to use to do control voltage output out to modular synthesizers and other synthesizers that use CV for modulation and pitch. So we have that also on I2C. And then I went a little wild and decided, why not put an OLED on there? So I'm using one of, I think it's this one right here. It's a 1.3 inch 128 by 64 pixel OLED, a little black and white OLED display. And that'll just give us the ability to do some menus or show the shape of the waveform that we're using, select between modes. I haven't written any software for that yet whatsoever. I don't even know if all these things will work together. I made the cardinal error of not actually breadboarding this, just because I was kind of in a race against time to get the PCB out and back so that I can put the project together in a timely manner. There may end up being bodging. There may end up being some of these parts not on there. We'll find out. But those are the components that are on there. And then to show you what that layout looks like, let me just hide this camera view here and bring on this PCB view. Where did you go, PCB view? There you are. Okay, so can you see that? Let me shoot that change over. There we go. So this is the PCB. You can see we've got the 16 faders arranged along the bottom there. And then from the left to right, we have our Itsy Bitsy M4. I made a special footprint for this that has this second row of headers on the sides. I didn't bother duplicating the bottom ones, but the sides I have extra headers there, and that, and maybe I should do the bottom. I, for some reason, just didn't think to. But the 2 sets of side headers, it'll look kind of like a cricket header or a feather wing header on the back of some of our devices. Do I have anything like that right here? I thought I did, but I don't. Oh, here it is. Yeah, here's a cricket. So you can see there, right? Those are the normal feather headers, except they're double wide, and so that gives you an extra set of pins to plug stuff into. You could use headers if you want, and just put little cables into them with DuPont connectors, or even hookup wire will work. Or you could leave that free and solder onto there. You could solder the microcontroller on, or use a socket or header. So you'll have a bunch of options there, but it just lets you pick other stuff to plug in that I haven't included on the board, because I think this will be a little bit of a kind of a development platformy kind of thing. Like, you build what you want with it. It's pretty open to your interpretation of how to use it. You can see up here in the upper left, I wedged in a little 6mm push button. That'll be the reset button. Next to it is a mounting hole. So this will be PCB with a faceplate of some kind, and it'll be an open back, so you'll be able to reach in there and adjust or press the reset button to reset the board, or double click it to put new firmware on. There are sort of ignore all these lines here, since I deleted my copper plane for ground. There's a bunch of stuff that wants to be connected that's not connected. But this is one of our two. These are the two 8-channel analog to digital converters, ADCs, ADACs, that are reading the faders and then sending that info over I2C. Here is the DAC output, so that'll have a, do I have that one here? No. That'll have it has a little screw terminal, so you could screw something into there, such as a headphone jack. If I do a revision of this, I may add an option with a switch to go out of the TRS output, this output here that's on the side. That could be either the DAC or either the audio out or the voltage out, basically. We could make a switch for that. And then next to that is the display. Here's our little OLED display here. And then the rotary encoder is to the right of that. And then I've got the little RC circuit capacitor resistor pairs here for this output on the side. So what this actually looks like in hand, we got to wait for the real thing, but in the short term, here is an earlier revision of it that I printed and cut out to the size of it. So that's what it'll look like. I've crammed those in pretty tight, so we'll see how that feels to work with. And then, let's see, this one is shedding its pieces, but you can see here, I just press the parts into the footprint to make sure that things fit, make sure that I got the right number of headers on there or pins on there, and so I put this together just to have a feel of what it'll be like. I'm right-handed, so I don't mind I like having my hand to the right of the display here. I'll use my right hand to change stuff there, but that could be a pain if you're a lefty, so maybe you'd want to rearrange this depending on how you work with your board. And that is off out into the fabrication world, and when that gets back in, I will put it together and see what I missed. So that's not going to be an Adafruit product, by the way. This is just a project. So I'm making a board that you can see. It's not using discrete components and things. It is using a lot of breakouts, a lot of Adafruit breakouts that you can drop onto there. So Jeff says I should wire the paper up. Yeah, you know, do I have any conductive ink left? It's probably all dried out by now. Some copper tape. That'd be fun. That'd be a lot of work. So that's the state of that. So we'll take a look at that once that comes back in. Let me know if you have any thoughts, questions, ideas. If looking at that you see errors and problems, please let me know. I am new to KiCad, and I would love to hear any ideas that people have. Okay, so I think it's time to move on to the Lego lighting thing. So let me jump over to the workbench here. And, oh, my main camera turned itself off. Let me go fix that. One second. There you are. I'll zoom that in a bit. Okay. Good, so let's take a look at this. This is a Lego Winter Village building that I have here, but this applies to kind of anything. The idea that I have here is that I have this collection of these little Winter Village houses that we put up every year, and there's also a little trolley and a train and some little vehicles. You can see some of these are pretty dusty. I've got to get in there and clean those off. They didn't get dusted last year. So these are adorable, and these, a lot of them, since they're these little cozy Winter Village buildings and vehicles, they have lights on them. And if you look at a typical light here, I'm going to zoom way in. This is H. Jolly's Music Store. I'm going to try to focus on this. So these use these translucent bricks, a little cylinder, one stud brick, and that represents a light, which is great during the day, but in the evening and at night, it would be nice to actually light these up. So Lego themselves don't really have solutions for this sort of thing other than one set of lights that you can put on some of the vehicles using their power up or previously their power functions types of sets. And they're pretty big. They're made kind of just to fit inside of a couple of specific pieces that are used often for headlights on their trains or some of their vehicles. So there's not a good way to light these things up. So there are third-party products out there. You know, if you recall, at one point I used some of our little induction-based wireless LEDs, which do fit in some of these, and those work really nicely. But what I wanted to do was try out some of these, which are these little tiny LEDs. Let me see if I can get that into focus. That are wired. This is a surface mount LED. It's a 0805 sized surface mount LED that has been, and I can't get close enough to even do justice to how tiny these are, but you can see there, this is a tiny little surface mount LED that's just been soldered at the factory to some really thin single strand wire. You can get these little 5-packs in the Adafruit store right here, and I'll show you those in a second. And they come in a few colors. They're meant to be run off of 3 volts. In fact, they probably say on here, yeah, 3V right there is for 3 volt. 5 pieces, 3V green. So these are green. We have pink and maybe purple. There's a warm white, which is my favorite, and I'm actually going to use pretty much exclusively that warm white to light things up. Now, the magic thing about these, first of all, they look good when you light them up. So let me demo that. So what I've taken just for some of my early testing here, and sorry, just one second, I want to bring up my Discord just in case anyone has questions. Bring that up. There we go. So for testing purposes, I took a couple of DuPont connector pins and carefully soldered them to the ends of the wire here so that I can plug that into a breadboard. And maybe I should have just socketed this coin cell, but I had already soldered that on there. But this is a little coin cell breakout that we have. It's actually got a switch. You can also use, there's one position on it that's just always on. And this lets me just plug in and run one of these LEDs for testing purposes. This is one of the warm white. I actually noticed there are some that are a little cooler. So a couple different, this one whole bag of them were cooler. Every other set of them I've gotten have a warmer, even more yellow tint to them. So if you take a look at the example of this little building here, you could see this is small enough to just fit up in there, I think. Oh no, wait, let me fit this one in from the top. Yeah, this one doesn't have a hole in the bottom of the fixture it's on. But you can fit it in there, and you can see, I don't have this. Let me see if I can adjust my... Oh, no, it's not going to let me adjust the exposure, but you can see there we get a nice glow. We get some light spill there. They look really good in the dark. I'll turn down a couple lights right here for a second. And I'll shade from the top there. So you can see a really nice look. And here's the magic part of it. These wires are so thin that you can actually put them under studs, between studs, basically click the Lego back together. So in this case, let me see, can I get closer? Okay. So in this case, I've got this little one stud cap that goes on top of there, you can set that light where you want it, say right about there, and put the piece back on. It will not break the wire, as long as you're careful with it. And the piece is really on there, so there's just enough tolerance in the Lego brick, and these are just so dang thin that works just fine. So now you can go and hide this, run it right into a crack between a couple other bricks if you want. Find your way to deal with those wires, but you can light things up that you would think, hey, that's probably impossible, right? I don't want to drill holes in these. You don't have to. They actually work just as I showed it right here. Another nice way to look at this is if I take this little strand, and what I've gotten in the habit of doing is twisting these so that it acts like just I've got kind of one wire assembly to work with and not the two separate like they come. So if I take that and use this, how about? If you need to run this between bricks, you can just lay it right under there. I'm going to turn the lights back up so you can see this a little better now. So you can, let's see, this is kind of a funny brick to do this with, but you can just take a brick and boom, it's on. Basically no gap. I'm sure there's a tiny one, but nothing noticeable. You can also, just for sort of strain relief purposes, you can sort of snake this over and under, kind of weave it. Around your studs like this. There we go. And sorry, I forgot to bring, how do I not have much Lego in here today? Let me look over here real quick. Here's a plate that'll work. So you can see here, we can just hide that just like that, and it's gone. There. So you can see there's a little gap there, but it barely disrupts the Lego, which is really impressive. So that's the idea there, and this will, I've just got the very thin wires that are on here, so it's a little harder to demo that, but you can see here if I carefully plug those into this breadboard, there we go, we've lit it up. It wants to fall out instantly. So that's the basic premise here. And you can see, let me grab this one out of here. Again, works well on that little yellow light there, but it actually will, I don't think you necessarily need to get a lot of colors of these for most cases, because the Lego translucent bricks do such a good job. Turn that on. Of they're so saturated that if I take, let's try this. Okay, so this is a little Lego Winter Village set of Christmas lights, right? So you can see it's just these translucent studs on here. I'm just gonna press that in there. That's actually a tough one because that's inverted. There's really not a lot of space in there, but you can see the color there. Oh, it's showing up very orange on camera, but it's actually very red, much redder than it looks there. So let's try it with the green one, see how that looks. Yeah, again, camera doesn't quite do it justice, but it's so bright. But yeah, you get a really nice saturated color. So I think just the white or the warm white will work perfectly fine. You can see there are also cases. Here's a little bus here. I'm going to refocus the camera so you can see the headlights on there. So the way these headlights work, they are made from what I think of as the lightsaber handles, and they happen to have a little white, or rather clear. Oh no, these aren't hollow. Okay, some things are hollow, those ones aren't. And on the hollow ones, you can feed the whole thing up and through. Let me show you an example of a lamp that works really well for this. I'll need to make some space because this one is connected. But you can see here there's some of these really cool street lamps. Some of them, this is a solid stick here, so you'd need to wire from the side here. But again, you can put it in there, get it where you want it, and then put that bulb back on it. I'll show you an example where I built that. And I'll show you an example where this does feed up through it. So I'm going to risk tipping things sideways to show them. Let's zoom out. So you see here, I haven't tucked these in very neatly, but I've got these wires that go into those two through the side. This one actually runs up through the stem. I did pull, there was a long piece running through the middle to give this more stability. But you can see here's a case where I've just run the wires all the way up through the whole thing. Everything was hollow, and the light is right here. So this brings us to point number 2, which is how to drive these LEDs and how to make the wiring make sense. And I think someone was making the comment, we don't really want to run these off of coin cells probably, so you could use some AA's or AAA's, but I'm going to run them through a microcontroller and an LED driver board, which means I can just run it off a USB power or a LiPo, however we want. So that opens up a lot of possibilities, including if you wanted to put things on a schedule, if you wanted things to be reactive in some way, if you wanted to put them on Adafruit I/O and make them wireless, anything is possible. You can see on the back here, and sorry, you can see I stole one of my color charts there to use that base plate. Here I've taken 5 of these LEDs. I have them wired into the little bakery set here and some of those lamps. And I have soldered them to some little JST connections. I think these are JST SH maybe, the little tiny Molex Pico blade style connectors actually. And then I have taken the other side of those, because we sell those in a pack, so I've got the sort of receiving side all soldered onto our LED constant current driver board. That's the AW9523. So this has 16 pins it can drive. You can tell it what current you want. So it doesn't dim and brighten using PWM, which flickers and doesn't look great on video. It looks fine to the human eye, but it doesn't look great on video. These actually have the benefit of being a constant current, so that you're really feeding it the voltage you want, up to 3 volts. And so now I have all these connectors where I can plug in these tail ends, kind of tuck this away somewhere, hide it under some bricks. So let me show you. I'll plug all these in, and you can see I've done some color coding here. So this is my first set of 8, and this will be my second set of 8. I haven't soldered all those in yet. And the color coding here is mostly just about being able to code your LEDs to do what you want without going bonkers trying to figure out which one goes where. So you can map that out once and then follow your color coding. So that's an extra that hasn't been done yet. Here's blue. So what I have in here right now are all the warm white LEDs, except for the one inside is one of those cooler white ones, and I'm lighting up the store window. with that. And when I get this all set, I'll point that camera at it and maybe dim the lights. Okay, so those are the ones I have set up. Let me grab a microcontroller. So that is an I2C driver, so I can run it. I'm just going to run it off of this Cutie Pie. And for testing, right now, all I do is bring up each bulb one at a time and then hold them for quite a while. So you'll see some of them coming on, and then eventually they'll repeat that cycle. So here's the little Cutie Pie I happen to have laying around. It doesn't need the breadboard connection there, but it happens to have it. Plug that into I2C, and then I'm just going to give this some USB power off a battery pack that's sitting here. And you can see, probably saw some lights come on there. Can I switch this? Yeah, I'm going to switch cameras now. That'll be easier. All right, so let's swap that over, and I'll see if I can point that a little. Whoop. And I'm going to take out this key light here. And there we go. So I'll dim that a little more. So you can see what I've got when these cycle. And I'm just going to power cycle it because I can't remember how long I told it to wait. So you see, actually, right now they're all just going to go to full blast when they turn on, then they turn off, and then one at a time, you'll see those dim up. So these are coming on over here. This lamppost one is coming on. I think the first one to go on, actually, did I not connect it? Let's see. Are you connected? No. I missed who? I missed you. Yeah. There we go. So that you should have seen the light show up on the inside of the bakery there. I don't know if I can show that in the other view a little bit. So you see all those little pastries displayed in there showing up. There's the light. So that's the idea behind it. I might do some vehicles and some other things too, but just lighting up these little beautiful little lanterns and sconces and things on there, I think will really give this a really nice look. There you can see, you can see the pastries light up. If you look right in here, that's when they're off. And that's one of the things with these is that these sets look really good, but you kind of have to light them. You can see that light coming up. Kind of have to light these interiors a little bit, otherwise you lose everything in the dark. It's just you don't see much inside of them. And there are, I may have mentioned, there are professional lighting kits out there that you can get. I haven't tried any of them. It looks like most of them are using a combination of LEDs. Some of them are basically this type. Others are little strip lights and things. I think some of them have built lighting controllers that you can use for flicker effects and stuff, but they're kind of take it or leave it. So the idea here is that we'll be able to control them any way you want. If you want some to be flickering so they look like oil lamps or candlelight or something like that, that's possible. If you want some to come on at some times and others at other times, all that should be fairly straightforward. I'm coding it in CircuitPython right now. What else did I want to say? Let me look. Yeah, train sets. These are great for people who are doing train sets. I think that's probably where some of these originally came out. Someone said, hey, wait a second, we got these tiny SMD LEDs. What if we just solder them to tiny wires? Then we can fit them all kinds of places you normally can't. And the other thing, kind of last thing I wanted to show, let me switch, bring the lights back on and switch out, is just a little tooltip kind of thing, which is since I have a lot of these to do, right? I'm putting together 16 of these on one board, and I want to use my little cable connectors to make it sort of plug and play. I had a lot of wires to prepare. Bring this zoom back out. And bring that back up. And Lars does not get to play with the Lego, by the way. Let me bring that view there and that view there. You could also do little tree toppers. There's some fireplaces in these sets that you could glow. But as I was saying, since I had a lot of wires to prepare, and you can see I wanted to twist them, you can see here is the next batch that I prepared. The way I'm doing that is with a little hand drill. So let me demo that real quick. See if you can see it. Yeah, you'll be able to see it if I do it kind of backwards this way. So here is one of these Pico Blade connector sets that we have. And so all I'll do is clamp one end. You can see I just have a little helping hand here. And then I chucked a little alligator clip with some protective rubber ends on it into this little hand drill. And then we just go like this. And that's it. Done. Next one. This is easier to do than twirling it by hand since we have a lot of them to do, and it's also, I think, a lot more manageable with this type of hand drill versus an electric. You could use an electric if that's what you have, but that has been really helpful. Also, I don't fear too much that I'm going to go too far and snap something because I'm just gripping them in these little rubber-ended alligator clips, so these will pop out if there's too much pressure on them. So that's what I did there, and then I've got little tiny bits of heat shrink tubing I put over these, tin the ends, solder them to the LED, which I'm doing the same thing to, so you can see these LED strands. As I mentioned, they start out life as 2 strands, and I'm doing the same thing, chucking them into here and turning them to put that little twist on them. That just keeps things a little more manageable. It would look like twice as much wiring out here if I didn't do that. And then, like I said, a little heat shrink color coding on here. And after, let's see, these I haven't finished yet. So yeah, this is a good example of, there's the two ends with their 2 little pieces of heat shrink, and then I'll slide another piece over that. I've been using clear, I think. Yeah, I used clear in most cases. This one happens to be a green LED, and so I put a green heat shrink there just so I could see that in action. And if you want to see that one running, I will just plug that in there. So that's that nice green one. But again, I'm not so sure it's necessary in this case because we always have these great saturated, translucent bricks to use, studs to use to get the color. So I'll probably stick with white just for simplicity. And so yeah, that's my little hand drill trick there that makes that a lot more manageable. Okay, so let me jump back over to the main machine here, see if anyone has any questions. Yeah, P. Karina Hurry said you could use the LED nudes. Those would work really well for certain things, for sure, especially like area lighting in a ceiling, things like that. I believe there are people who have made lightsabers for minifigs that does involve a little bit of drilling to get the LED where you need it and hide things, but it's kind of fun. Let's see. Josh Mann says, this is magical. I know, right? Lighting up Lego sets. They're made for it. There are so many. Look at these. We've got these cute little street lamps made to be lit up. We've got these tree toppers. Those will diffuse a bunch of light through them really nicely. Here's this little bench here waiting to be lit up. There are just a lot of opportunities. And then also things like these little stands, like here's a little Christmas tree stand. You can put LED in the top of it, and that's just going to throw light down on the vendor working there and the top of that. So it's easy to find cool ways to light these up. Also, you can, like I said, you can run them off the coin cell. You can, with probably a resistor, you can run them off of a AA or AAA battery pack. So you can keep it simple, or you can do like these animated effects and things by using the driver board. I'll show you real quick. This is the driver board that I'm using for this. Oh, let me show you I'll show you also those are the LEDs I'm using. So this is the warm white miniature pack. And there's a good indication of what that is, right? Tiny little surface mount LED that has been made for you. You could build these yourself too if you really wanted to, save some money. You could get surface mount LEDs, you could get some single strand hookup or like bodge wire or even magnet wire if you have a good way of dealing with the enamel on those. But yeah, you could make these yourself or just get these little packs of them. And here is the AW, what's his name? 9523. That's what I'm using. This one also, one nice thing about this is that, so you place the ground side, which is the blue wire on those LEDs, you place the ground side in the numbered pads here, and then all of the positive side, which is the red wire, go into these voltage in, which is going to be your 3.3 volts coming through the I2C. So those are all on the same line, but it's kind of really nice that you have them replicated all the way. So thank you, Lady Ada, for doing it that way. It means you're not trying to fit 16 wires into one hole and then the other 16 are spread around. It actually makes this a lot easier to socket and work with. So I really like this board a lot. It's you can get 2 of them on one I2C bus, I think, or maybe more. There are 2 jumpers for address. Yeah, so it's probably more than that. It might be, I don't know, 16 of them or something like that. I used these for my step sequencer, which is buried in a box over there. But yeah, the little LEDs to light up 16 of them, I used one of these, so they work really well. So that's one possibility. I will probably, for the guide, make both CircuitPython, hey, here's how you can code this, and I'll probably make a pre-made UF2 file for someone who's less experienced with this, who just wants to drag and drop a file on that does some, the first 8 of them are doing one thing, the next 4 are twinkling, the others are randomized. We can build a little preset for people if they want to do it that way, and then just plug them or place them where they want based on the behavior that's predefined. So those are some options with those. I think that's going to do it. Again, I will mention it takes a village, specifically a Lego Winter Village, and that is your coupon code for today. That will get you 10% off in the Adafruit store. So if you want to go pick up some stuff, maybe pick up some of these LEDs and play around with them, get yourself a driver board and a little cutie pie, and you're off to the races. Also, there's a really nice set of Lego compatible 3D printed board connectors that the Ruiz brothers have done. You can look around for those guides. I'm going to use some of those for mounting a cutie pie, which doesn't have mounting holes on it, but they have a little snap fit, click in place, plunk that onto the Lego hidden behind a building, and I'll remix one of those to work with this LED driver if they haven't done that already, but they may have. So that'll be a way to put these in the back of the scene and lock them down to the base plate. All right. I think, unless there are other questions, that is going to do it. Yeah, so use that coupon code. That's going to get you 10% off today. And that's all I got. So I will see you on Tuesday for my product pick show. I will not be doing this workshop show next week. It'll be Thanksgiving. So enjoy. If you celebrate Thanksgiving, please enjoy your Thanksgiving and eat a bunch of good food. All right. That's it for today. Thank you so much, everyone, for stopping by. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. Bye-bye.
Thank you.